My name is Antti Alestalo. I'm going to talk about this acronym monster called ERTMS/ETCS. Basically, I'm going to talk about trains and railroads. So if you like those, this is a good talk. I'll also talk a bit about cyber, but it's maybe a bit more about the trains and railroads than cybersecurity. Okay, just short intro. I used to study at the Helsinki University of Technology when it was still called that back in the day. And after my studies, I worked some programming jobs and then moved to cybersecurity at KPMG quite a long time ago. And I've been a freelancer now for 4 years already. And the slides are obviously lagging a lot. Let's see if it worked or not. Okay, maybe we'll go 2 slides now. Okay, some words about my background. So all these places are actual sites that I've audited in somehow in my cybersecurity work. So I like to talk about industrial control systems. Some people say OT, so operational technology. For example, we have here, if I can just see the laser, oh, it's really weak. Here, top left, there is an iron ore port in Brazil. I think top right is a paper mill in Belgium. In the middle, we have the largest aluminium smelter in the world in Abu Dhabi. And most recently, railroads in Finland. This is actually from, I think, Turku train yard, where I did my first railroad project. Okay, let's talk first a bit about railway environments. What is the typical things we find there? Well, so in Europe, we've had railways for, I don't know how long, 200 years or something. And it's a quite integral part of the infrastructure. And at some point, someone realized that maybe it would be a good idea if trains couldn't crash into each other. And that was obviously seen as a positive, and then people started implementing systems called automatic train control. So you cannot actually run a red light with a train if you have this system installed on the track and then on the actual train itself. But as it usually goes, everybody wanted to do their own system. And this is the result of that. So we have, I don't know even how many different systems in Europe, but let's look at Britain, where the railroad started. They have 7 different systems there just on the British Isles. So this is, of course, a huge headache for, especially if you want to run a train, let's say, that starts from Paris and goes to Brussels and Amsterdam and then goes to Berlin or something like that. God knows how many different safety systems you need to have to be able to do that. I know that in Europe there are trains that run 4 different automatic train control systems in the same locomotive. And that's, of course, expensive. You need to install each of them. It's always difficult to fit in 4 different systems. The train driver needs to know how to operate each of those systems. So this is actually, it costs money, it costs to train people, you may need more people to drive those trains and so on. So this is the, let's say, current situation. There's been some progress, but this is the future. So even though these systems are called European train control system, it's actually seen as such a good idea that all these countries have adopted them or are planning to adopt them. So it will be maybe an international train control system. Okay, we have a question here.
Why is the US missing here?
Oh, why the US is missing? You know, they cannot use anything except things that are made in US. So I was thinking the same question, but I don't know the real reason, but I would think that is the reason. They do have this huge infrastructure project starting there, and we've seen the news about the train crashes in Ohio, so maybe they could use this solution. I don't know how if they have one system or multiple systems. If they have just one, then maybe this is not such a big issue for US. And you see China is a bit different color. That's only because they removed the E and replaced it with a C and called it the Chinese train control system. But the standard is basically the same. But this is the, let's say, future, but if we look at how many tracks we have with these technologies, it's not that much. Let's see. Okay, so you see what happens when shit hits the fan. So when these systems don't work properly, this is the result. This is just a few weeks ago in Greece. Freight train on the top left and a passenger train here in the bottom crashed, killing over 50 people. And you can read the text here on the right, and basically what it says that there was an automatic train control system there, but it was not functioning. In addition, the signals, basically traffic lights for the railroad, were not functioning either. And it's a wonder that it hadn't happened before, because this was the situation for quite some time already. And I don't know what the results will be, but I think some people will be going to jail for this. Because it's a very serious thing to neglect these safety systems and getting 50 people killed. All right, let's talk about the acronym monster then. So this ERTMS/ETCS is a standard developed first in Europe, how to manage traffic and control the train movements on the tracks. And it consists of two parts. Nowadays, actually, the ETCS is kind of underneath the ERTMS, so the actual traffic management system has the train control system inside of it. But those two acronyms are the typical ones. I actually tried to avoid of adding more than these acronyms in this presentation because there's so many. I've had to learn maybe a few hundred in the last year and a half. Or maybe not that many because I'd forgotten some of them already. So, but there's a lot of acronyms here in the railroad world. Okay, so let's look at the architecture. What is the typical components then if we talk about ETCS-based systems? So we have here on the left, we have a so-called rolling stock. So the trains, the cars, anything that moves on the tracks. When we move to the ETCS system, there will be a couple of important components. So there will be this onboard unit and a driver-machine interface. So the onboard unit is basically a computer that checks that the train is running as it's supposed to be running. And then the driver-machine interface is for the driver to see what is happening, what is going to happen when he drives along the track. And then we have a multi-channel router, which is basically a mobile network router that can then talk to this trackside infrastructure. And here in the center, we have things that are on the track side. Currently, for example, if you ride on a train in Finland, and you will occasionally see this red brick building next to the track. It might actually house some of these items here. It doesn't have this radio block center or the mobile stuff yet, but this interlocking, which is the kind of the brains of the system that decides which train can go on what track and how fast it can go and so on, and how far it can go. In the future version, we'll have this future railway mobile comms systems, so ERTMS, which is a mobile network solution so that the track side can talk to the train. And then we have this radio block center, which is basically a computer that handles some of the same stuff as this interlocking computer or PLC or whatever type of device it is. It's also possible that this will be actually just one solution that does both of these functions, but the specification doesn't really care which way you do it. And then finally on the right we have traffic management system and actual people who will assign permissions for trains to travel on a certain path. For example, the train leaves from Helsinki and it will leave from platform 9 and then travel on track so on to Pasila and then go from Ilmala towards Lahti, for example. And that's always decided by the traffic controller. But if things go well, it's pretty automatic. So this interlocking system will take care of all of that stuff. Okay, now this is the simplified architecture. We have one question.
What does the onboard unit, what actions can it do? Can it brake, can it accelerate?
Yeah, so question was, what can the onboard unit do? The most important thing is for it to do is to brake. If you try to run a red light, basically. It can do emergency braking if you do that. And it will communicate with the radio block center and show the data to the driver. It can actually, we'll get to that part at some point. It can actually, if we install a component called automatic train operation, so it can accelerate, it can do pretty much everything except open the doors. So there's a lot of stuff. Even if we go, I think it's automatic train operation level 4, then it can also open the doors. So there will be no driver in the train. There will be just a, in English it's not called conductor because that's the driver of the train, but basically a ticket salesperson who can just press a button that the train is ready to depart and then it will automatically depart. But one of the most important things the onboard unit does is it calculates a thing called braking curve. So it knows how fast the train is going, it knows how fast the train can stop, in theory, and then how far it is allowed to go at the moment. And it must also then know the location. And then if you run the red light, it can start the braking immediately. Or if it knows that, okay, your movement authority is about to end, it can engage the emergency brakes. There's a lot of other stuff too under the hood, but that's the most important thing. Okay, this is now the real architecture. So as you can see, there's a lot more stuff. Don't bother reading it, it's not important for you to understand. If you're interested, you can find this, maybe this was shift to rail documentation. I can't remember where I pulled this from, but you can get the slides later if you want to look at it in more detail. But you can see there's a ton of different systems. There's everything from public services for passengers like wireless connectivity and electric supply and train public announcement systems and all kinds of stuff. That's not really important on the safety side, how the train runs and so on. Okay, I talked about this a bit already. So in the ERTMS, that includes the ETCS part and then the traffic management part. It defines the mobile network for the trains to talk to the track side. And it can have this automatic train operation component. It's not mandatory to implement that one, but I think that will be the future, let's say, 10 years plus. Maybe we'll actually get some automation on that. The first, like, there are a couple of grades of automation. It's called grade of automation and depends on what the driver does and what the train does automatically. And I think on level 2, for example, the driver just pushes that, okay, let's depart, and then the train will accelerate and brake based on the speed limits on the track and everything. And that's mostly for energy efficiency. So it can optimize a lot of things on the train, how quickly it accelerates and so on, because people are imperfect in that sense. And then we have the ETCS, which is the actual safety system. So it's a safety system that the trains don't crash, and then it forces also interoperability between the countries. So if you have a ETCS equipped train and all the tracks you run on are ETCS equipped, then you can basically go to any country that uses ETCS and just use the tracks there. There are some things that need to be agreed. There are things we'll see later in the presentation that need to be handled, but at least in theory, that's a lot easier to do, for example, like key management for some encryption stuff that we'll get to later, than to install a whole train protection system on a locomotive. Okay, so in ETCS we have some levels. Level 1 is that the trains actually get instructions from balises. And those balises are actually antennas that are between the tracks on the railroads. You can see these in Finland nowadays too. They are balises, but they are not ETCS balises. But if you go on a train and look at the track next to you, you will see this big yellow plate basically between the tracks. And usually it's always that there's two of them, maybe 10 meters from each other. Those are actually antennas that will tell the train where it is, and maybe some other information. The current system doesn't really talk to the train that much, but on level 1, for example, the balise could tell us that, okay, tell the train that, okay, you can now continue next 20 kilometers on this speed, and a bunch of other stuff. There's a lot of things there, but like that's the most important thing. On level 2, you will get the mobile network included. Currently, all implementations use GSM. I'll get to that soon. So that's a bit ancient technology. It's a version called GSM-R, but it doesn't really differ that much from normal GMS. On level 3, it's the same, but the train actually locates itself. So the train knows where it is and also monitors that the last car in the train is still there, so it's intact. Because that's very important on railways. It happens that trains break apart, and if the driver of the train can't see, is the last car there. So you need a system called integrity monitoring on the train, so that when you go past certain point, you can then say that, okay, now the track behind me is actually free. currently on the railways we use systems like axle counters. So you run over a device beside the track, and it actually counts how many axles pass that point. And at the other end of the track section, there's another counter that then reduces the axles, and then it's okay, now I know that no axles exist between these 2 points and the track is free. It's quite simple, but then a bit complicated when you translate this to all the traffic management and so on. But on level 3, you can actually dynamically reserve the track. So currently it's always like, let's say, 20 kilometers or 5 kilometers, and that's the part that's reserved for you. And it can be sometimes really long, even 30, 40 kilometers. And the train doesn't need that much space necessarily. So on level 3, you can actually put, if it's a long track, you can put 3 trains running to the same direction on the same track, and it still be safe. That's something that you can't do with the current system. Okay, now in Finland we have this DigiRail project that I'm working with. We'll try to go directly to ETCS level 2, and we'll use that future railway mobile system to talk to the trains and the truck side. And hopefully we'll use commercial mobile radio network operators here, so that we'll actually use all 3 of them. So Elisa and DNA and Telia will all be always on the mobile router that you saw. That's why it's called multi-channel router, so you can always switch between the operators on the fly. So if you lose connectivity on one of the operators, it automatically switches over to you, so you don't lose connectivity between the train and truck side. But there are some challenges there, and we'll get to that too soon. And hopefully, after we get the first track on level 2, we'll actually get to level 3, and we'll use those semi-autonomous trains, so that the driver only needs to push a button when the train is ready to depart, and then it will automatically do all the braking and acceleration and stopping on the station. And the driver will be there mostly for safety reasons. So for example, if there's something unexpected on the track, he can emergency brake and so on. And we are actually procuring right now this first track, and it should be in use in 2028. We'll see if we get there. It's a bit challenging, but hopefully. And there are 2 reasons why we are doing this in Finland. One is that the current system is basically a rusty piece of junk. And if you, for example, see that trains are running late because there is a turvalaitevika, so interlocking problem. So that is the old stuff that is breaking down. Or one of those axle counters is broken and didn't count the axles correctly. And then somebody needs to go there with an iron shovel and just slide it over the tracks and hopefully make the axle counter reset. I've heard about this one. This is not something you're supposed to do. You can actually go over the network and reset it, but sometimes that's not possible, and it's quicker to use the shovel method. And hopefully we'll also get more capacity on the tracks, because a lot of Finnish railroad is single track. So then we could run a couple of trains closer to each other in the same direction. Okay, we have a few challenges right now. So the first version uses this GSM network for railways, and it's dedicated. It's only for that use, nothing else. And I don't think anyone should be building dedicated radio networks for this purpose only in 2023. In addition, we don't have any GSM technology in Finland anymore, so that's a challenge. And the future spec is not ready. It's not out yet. We don't have anybody who can provide us with the necessary technology to implement this network. So let's see if we get to that 2028. And we are supposed to have 5,000 kilometers of track done by 2040. So we'll see how it goes. So the specs are not necessarily ready, and then are the vendors ready? Do they have some products that we can actually buy? And after I'd made this presentation, I heard about some changes. So this technical specification for interoperability, so TSI, is not ready. As you can see from the number, it was supposed to come out last year. Well, it's not out yet, which give us some challenges. So the baseline 4, which is basically a new version of the standard, we don't have it yet. We have all the drafts and everything, but it's a problem because the vendors can't finalize their products if they don't have the final version of that standard, and then we can't buy anything. And then this new mobile network is not included in baseline 3. Should we then build GSM-R network? That probably would be very expensive. Hopefully we can just go around that and say that, okay, we'll use 4G, and this is how we do it, and then get some kind of exception for the first track. And those levels, that's all gone already now. Level 2 and 3 are now combined in level R, just that it wouldn't be easy to understand these. I don't understand this change at all. It wasn't necessary. So, but here we are. Somebody had a great idea. Okay, then let's talk a bit about cyber. So we have a bit of challenges when we talk about railways. When we try to do cyber, first of all, we have a hugely distributed system. We have 5,000 kilometers of track, and we need to put some things on the track side too. Maybe not as much as before, but at least some. And how do we, for example, do physical security on all those small brick buildings next to the track? Then we use wireless. That's of course a challenge because radio communications goes everywhere. Everybody can hear it. It's not a problem or a big problem if we can use 5G, for example. But if we have to use GSM-R, it's not secure. So that's not very good. And if we use the commercial operators, it's also a problem because then it's a shared environment. There are other people on the same network, basically. We can actually go around that a bit by using prioritized SIM cards and things like that, basically paying the operators a bit more so that we have a better quality of service. Then we have some risks related to train positioning. So there's a lot of technologies there that we try to use to find out where the train is. One of them is GPS. You probably heard about GPS jamming that has happened in Finland in the recent years. So that's a bit area that can be a problematic. Did we have a question?
Yeah, about the wireless networks, the coverage.
The coverage, because you had this nice example before, Helsinki-Tampere, and everybody experienced plenty of not covered areas there with relating to.
Yeah, if you have a phone
yeah.
on a moving train, yes, that's a problem. But we have better antennas, and then we will be able to work with the operators to maybe put some fine-tuning on the mobile network so that we get better reception. We have actually done this measurement in all of the tracks in Finland, and 4G is 99.998 or something.
So are we going to get better
No.
coverage? No, only you. Okay.
Only us. Yeah. Actually, VR has a separate program for the customer network that will benefit from the same technologies, but it's not something that we use for the train control, because we don't want you guys there on the same network as we have the safety system, especially you guys. Question.
Has there been any thought put into the okay, Mike, cool.
Yeah.
So has there been any thought put into the a third rail, or like this signaling by the rails, like this, how to say it
You mean having a
signal running into the because it's a physical contact all the time, I guess. So it could be.
I have no idea.
Okay,
I know that radio is a bit cheaper.
Yeah, it's cheaper. Yeah, sure.
So I don't know how would that work in practice, but no. Okay, next question.
Yeah, just out of curiosity, so who owns the specs that we are now talking about? I mean, GSMR is 3GPP, but what about these radio, other things that you are now referring to?
I don't actually know exactly, but there's a lot of European rail organizations that are part of defining these. So it's basically an open standard, but it's been defined by the railway undertakers, so basically the people or companies that own the trains, and then the infrastructure owners of the governments and so on who own the tracks. So they all work together on this standard. There's EU legislation on this. For example, you're not allowed to build new tracks in Europe, in EU, unless you use ETCS. So it's a European cooperation thing.
Okay,
One more question there.
You mentioned the GPS having some problems for the tracking, and one good example of it is the HSL ticketing machines on trains. They seem to constantly lose GPS location and won't work because of that. So I assume it has a lot to do with the same thing here.
I don't think we have those jamming things that much here. We have one more question in the back. We don't have that jamming thing going on a lot in the Helsinki area right now. But there's a lot of, like, for example, the car itself, it can jam the signal, so we'll actually have the antenna on top of the train. And we have other ways to locate the train than GPS, because it's not accurate enough, especially when you're moving really fast. Yeah.
Yeah, what about sort of catastrophic events or like intentional disruption by other countries or something like that? Does the standard have any sort of requirements for those situations where the internet goes down or?
No, but we are looking at that stuff too naturally in cyber. So I have something for that later in the presentation. Okay, let's move forward. I have no idea how much time I have left. There are some interesting choices here for security. So, for example, triple DES is used for encryption in some points. There's actually MD4, so not even MD5 in one protocol that's under this whole giant umbrella. It's leftover from 80s or something. But sometimes you can't change that because then you would break a lot of old stuff. And the wireless is, it's not encrypted. Like there's no transport layer encryption there. There's only a message authentication code, so a signature at each message that is sent to the train or the train sends to the trackside. And even emergency messages, they don't even require the authentication code. So in theory, you could send an emergency stop to all trains if you have a nice radio. In theory, it's not that easy, but could be possible. Okay, more questions?
I think Finland ditched the GSMR and now uses like Tetra or something, like viranomaisverkko.
Yeah, that's a different thing, but yeah, go ahead.
Okay, no, I just thought because it says no encryption, but Tetra has encryption, so it would kind of be a downgrade.
Yeah, but so
Okay.
5G has encryption. So if we can use 4G or 5G, it has
Okay,
encryption.
so this is only for the messaging to the train and not
Yeah.
like voice messaging and such.
Yeah, that's a different thing
Okay.
also. Currently they're using that, and there will be a different solution for the voice thing that's not integrated into this stuff at all.
All right.
But it's part of the standard still, but it runs on different hardware and everything. Okay? And the encryption is not that, if we use 5G, it's not that critical on the radio way, but it will also travel on the wires, so on the operator wire network, it won't be encrypted, for example. Okay, one more challenge. Almost no one in this country has experience in railway cybersecurity. I had 6 months of experience, so doing 4-week projects that just lasted 6 months. I had most experience probably in this country. Actually, Chris, who is somewhere here, back there, has the same experience. But now we have 3 Finnish guys working on this, and so we are getting there maybe. But we still need more people. Okay. Then how do we solve this? First is design secure systems. That's the most important thing. I will have more on that later. Then we have these different standards. I don't want to go all to the numbers. They say a lot of things is required, but they don't necessarily tell you how to do things. Like what should they say, okay, segment your network. Yes, I know that. So, but what should be the more detailed implementation on that? Okay, but we can, of course, solve this. Just take some IT stuff and try to fit it in the OT world. So we have secure architecture. We can do passive network security monitoring. Hopefully, we'll have anti-malware, maybe even application whitelisting. Hopefully, we'll have centralized access control for all the stuff that's on the trains and on the track side. Hopefully, we'll have traffic encryption. Now, this all hopefully because they're not there yet. But we'll try to implement them, and maybe in 2040 we'll have those. But as you can see, this is not IT. Things don't move quickly. New technology doesn't arrive like this, that you buy a new thing and install it in your network, and now you run it, and maybe it doesn't work correctly the first time. But here, it's very important for it to work correctly right away. Question?
So yeah, what is the constraint that is that preventing us to go forward with this, like 5G or the latest technology? Is this a policy or is it?
It's policy, yes.
Itself? Okay.
And the standard doesn't know 5G yet, so we are waiting for the baseline 4 that could support 5G and so on. And then it's also the vendors. They don't have the stuff ready yet for all these new technologies. So you cannot change things as quickly in the OT world as in IT.
Mm. Yeah, and also in the slide I saw that PR is creating or developing building the own dedicated network for GSM, which is, I suppose quite difficult, of course, in this time.
Mm-hmm.
So why don't we use this? Finland has own government security system, this own network. I don't know the name, somewhere something.
I
think it's used
Turvaverkko.
and used by police and government.
Yeah, so it's not suited for this. Okay. It runs somewhere completely different than the track side. We need stuff that goes along the tracks, for example.
Oh, okay.
And we don't want those guys in our network either. Oh. So we need to be isolated. So that's part of the secure architecture, like isolate stuff.
Okay. Thanks.
Okay, so then we have another challenge is this old versus modern. So here on the left we have a Siemens West-Trace Mark II, maybe from the 90s, late 90s, early 2000s. This is actually not that old for train stuff. The oldest stuff in Finland is actually is relay in English. Yes. Yeah, so relay-based stuff, things that go and do computation like ones and zeros and really big machines that are size of the wall that do some parts of the rail network still. But this is a modern stuff here on the left, and then this is the really modern stuff on the right. So we might actually have Linux-based RBC, for example. So the radio thing that you saw on that architecture slide, it might be a Linux-based server, basically. So one challenge is that how would you secure this one? How do you even know what's inside that? You might not even know all the interfaces on that thing. So it can be a bit challenge to secure. How do you harden it? Can you change the settings? Maybe you can't change the settings. Maybe they have a backdoor there that's password is Siemens1, and you need to just connect to a certain port with that password, and then it will talk to you always. A lot of challenges there. But then again, this Linux is a lot more familiar to all of us, or most of us at least here who work in the cybersecurity. Maybe it's easier to harden this part, but then you have a lot of stuff in Linux too. You include a lot more code into your solution, and the hackers also know Linux really well, maybe better than the defenders. So there's always some kind of, you need to wait which is better, the hardware stuff, or maybe you want to go more software. Okay, some examples now of the defensible architecture. This is the best way that we can stop attacks. If we really build the system good from the ground up, then it's much easier to stop the attackers. But it needs to be designed, and then it needs to be maintained, which is maybe even the harder part. So you need people and processes for the latter part, so that people don't do silly stuff and bring a Wi-Fi base station and connect it to some network because they want to work in an easier way. We have built this reference architecture. It's not version 1.0 even yet, but we are working on it. That's something that the vendors should look at and implement their stuff then roughly according to that one. And then we have also done something I wrote, is the threat landscape for the DigiRail project. So looking at, for example, the attacks we've had in Europe on the railway infrastructure in the last year. Luckily, I timed writing that really well, so the stuff started to come out just when I was writing it. So we could take that into account, that when we think about what are the current threats for our environment. Okay, then we can do, for example, network security monitoring. We can't do all the fancy stuff we do in IT, so scanning for vulnerabilities and actively hunting for things inside the devices and so on. But we can do passive, we can listen to the traffic, maybe we can use some management interfaces to look at security settings and things like that, and get some logs and so on. But the challenge here is that you need a device that actually understands the railway stuff then. Like if somebody is sending commands there that make no sense, that would always be like a red flag. So, but the network monitoring must then understand that, okay, someone is sending commands that are maybe malicious. And as it can't be very intrusive, so safety is always the top dog on railways, because well, getting people killed is not fun. Then we have a problem. How are we going to cover all this network if we have 5,000 kilometers of track and 5,000 kilometers of fiber optic cable running around Finland? Are we going to get all the traffic that we need? What about trains? Can we listen to the traffic that's inside the locomotive? Maybe. Then we need to integrate all this to CM and SOC solutions. That's great, we get the data, but then somebody needs to understand what those alerts mean and what they need to do with that stuff. That's always difficult. Okay, then we'll get to that encryption stuff, like how can trains now trust commands? 1 minute for the question. So, solution, we have a key management system. Each device, so train or trackside safety device has a key, and we'll use that to sign the message. Okay, great. Okay, how do we manage the keys? How do we get the correct keys to the correct devices? Solution, let's use online key management system so we can use the internet for sending stuff. Great. New problem. How do we keep the keys confidential when we send them over the internet to the trains, for example? Solution, let's use TLS for that. Okay, we have a new problem. How do we handle PKI? So it's encryption all the way down. I don't know how many layers we'll need, but it probably will never end. Okay, questions. We had one there in the back. Oh, first one there. Go ahead.
Here, in the dark.
Yeah.
So one question is, so you have this railway system all around the world, but is there a system like this that is created for trams and systems that are basically more local? Because could you use the same system basically for trams as well? Or is it just the focus of the system based on the train networks?
I'll say for metro, yes. For trams, not as good as we have a lot of other traffic on the roads where the trams go. So trams are more challenging.
And then the other question, second question. So you said that you have basically problems with vendors and things like that. But for example, if we are talking about Finland, Finland is quite small compared to Germany, where there is a lot more railway traffic. But also in Finland, the coverage of normal, let's say, networks, commercial networks is a little bit better in many cases. So would you think that in cases like Finland, it would be actually better to utilize something like 4G and 5G and just forget about like this custom systems?
Yes, and that's why we are trying to get there. We are not there yet, but we are trying to actually lobby this in EU to get the permission to do this, because our mobile networks have been proven to be reliable already. So we can, there's, I think, literally 4 places in this country on the tracks where you can't hear any of these operators. There's actually, I'm not sure if it was published, but there's a paper by our network team that covers this thing. Okay, we've reached the time limit. Hopefully we'll have a few more questions, time for a few more questions. If we can pass the mic. Okay.
So what's the latency budget in the train? How often does the train need to communicate with the network? Once a minute, every 10 minutes, constant connection?
More often. So there is latency, first of all, is, I can't remember what the limit is because I'm not on the network team, but there is a defined latency, but we are really good with the current 4G network already on the latency side. And then I think the disconnect time that if you get the disconnection, there's 40 seconds is the standard that says that 40 seconds is the time. But it will depend, then we can set a national value. We probably would set it a bit lower in Finland, except if you run on a certain track where we know that you have a small gap, then we can set it longer there. Then in the back, we have 2 questions there in the back row.
So obviously there are other European countries implementing this. Do you talk to them, and did you talk to them to figure out about the cybersecurity issues?
Talk to who?
To like other European countries who are implementing the same similar or same systems.
Yes. So we have cooperation organization called the EUG, so ERTMS user group, which is formed by the infrastructure owners, the railway undertakers, and all kinds of people, and we have a security core group there. So we try to solve these things with them. I don't do that work, my colleague does that, but there's a lot of things happening there. Then there's one in the same row. Thank you.
Thank you. In your presentation, you're talking about isolating the network and having your own network. In the same time, you're saying you need to access internet, and this seems so basically you are exposing the entire network.
Sorry, I didn't mean the actual internet. I was just meaning the same network. So it's public network in the sense that it's from the mobile operators.
Yeah,
but it's an isolated part of that. So we use something called APN. So I can't remember what that means, but basically a private part of the mobile network.
Yeah, but is it possible to isolate the entire system from internet? Because in the past, the ICS...
We try, but it's not, we don't rely on it only. Like our security is not that we are isolated and then everything else is, we don't care. We have multiple layers of defense because of that. So we try to be very isolated. So for example, here, you shouldn't be able to do any communication to any of that network. But it's possible that maybe there's a malicious insider at the mobile network operator who does something bad on the network. Maybe you could have nasty things happening, but we'll try to protect from that guy also. So, next.
Yeah, I think you briefly mentioned some attacks you have seen in the past.
Yes.
And can you widen that at least a little bit? Like what kind of, are they like constant campaigns? Or
I can't talk about all of them. It's not public, but it's not very secret either. But in Ukraine, we saw some attacks on their infrastructure. This is based on information from Traficom, basically. And then there is the Belarusian railway network that has been attacked. I think it was mostly on the traffic management side, so not the safety side. Basically trying to stop the Russian troop movements on the Belarusian railways. And then we've had some attacks on Italy, Czech Republic, Poland, and maybe something else, but they've all been non-safety attacks. So things that are related to trains, but not necessarily, they can't make them crash. And it's not sure if all these are attacks because of the Russian attack on Ukraine, or if it's something that happened at the same time. Okay.
Does the train drivers' strike affect on your project?
No. Short answer.
Sorry. So how are you making sure that in the end UK doesn't have 8 competing security systems for the rails?
UK, I don't care.
For example, UK or
they're not in the EU anymore.
Yeah.
Okay, actually, it's the job for then the UK government. I think they're still committed into using this ETCS-based system, and they have some tracks already that use it. Basically, like I said earlier, it's illegal to build tracks with some other safety system than ETCS at the moment. I don't know, like you don't go to jail, but the EU will come knocking and say that if you don't do ETCS, we won't give you any money for your infrastructure projects. So that's why we are actually in a hurry that we want money from the EU for the DigiRail project. Wrong way. Last slide, please. Yeah, this one. More questions? We have one here.
The human-computer interface for the driver, it probably has many similar problems that have been solved in air traffic. For example, can the driver bypass the system? If it's highly automated and it goes on and on, how do you keep the driver engaged so that he has situational awareness when something happens?
Well, first of all, the computer is the boss in a normal situation. And when a trip happens, it's when the emergency brakes engage. You need to go through a process to unlock the brakes. And then there are many operation modes for the locomotive. So you have, there's actually probably 15 at least, all kinds of things like shunting, which is like arranging the trains on the train yard, and then there is on-site, which is basically that the driver is responsible for checking that the track is free, and then there is something that's very similar, but I can't remember now what the term is. But basically the computer can go into these modes where the driver can actually cross signals, but then it will limit the speed of the train, for example. So you can't go faster than 35 kilometers per hour or something like that. And it depends on what the mode the train is. And there are strict rules on what the transitions can be. So you can't go from FS, which is fully supervised. You can't just switch that to other mode. There needs to be a process to do that.
Is there technically a way for the driver to completely disable the computer and take manual control of the train?
I have no idea. Maybe. Maybe. Yeah. So, pass the mic to the center. More questions? We have.
Basically, continue on the previous discussion. Trains have deadman switches, and they have them for a very long time. So if the driver falls asleep, the train will stop.
Yeah, deadman switch. Yes.
Yeah, that has been there. That's even in today's train, and probably also in trains from like several decades ago.
Probably almost 100 years ago.
Yeah, and I think trams and metros also have these deadman switches. So if the driver falls asleep, the thing will just stop.
Yeah. There's one more here, again in the front. Yep.
You mentioned that there's the train integrity monitoring.
Yeah.
But does this system also include something for the rail integrity?
No.
Okay.
If the rail has a physical problem, then the driver has a problem. And the train probably won't, the driver can't see that problem before it's too late already, because the trains stop so slowly. Maybe the flirt, the passenger trains, the modern ones can stop in some cases, but it's an issue. But it usually can cause an accident, but it's not typically catastrophic.
Yeah, just coming back to the earlier topic about encryption all the way down. So I have a colleague of mine that is working on the area of railway security, and at least one topic that he's very much into is the kind of building up a root of trust using TPM or similar, and then kind of building remote attestation as one way of establishing a baseline that allows you then to kind of build up any kind of PKI other solutions. So are you involved with any of that type of discussions?
I'm interested now, who is your colleague?
We can talk more at the burger.
Yeah.
So.
Yeah, so there is a solution. So the PKI system is actually defined, how do you implement it and so on. But there's always a point where you need to take something manually somewhere. So at least the first installation of the TLS certificate, when you get a new onboard unit, you need to actually go there and install the certificate to the onboard unit, and then you can use this online stuff. So one question in front of you.
I was just asking with regard to the reason why US is not involved into using a system like this. Is a fear that there might be a backdoor and that the people who conceive it can always get in.
Yeah.
But now, given that England was one that conceived these, and they are not really part of EU again, what precaution have EU taken to ensure that even if England is not part of the EU, they cannot have such privileges over the system?
Well, basically, Thales does provide these systems, so if they can bribe Thales to install backdoors, maybe they will have, but I don't think so, because the system vendors would probably never allow that even for CIA or anyone else to do it. But you can't, if you have really top-notch physical backdoors or some kind of implant on the hardware, you can never be sure.
Hello, Antti. Thanks for the presentation. Have you thought about fixing the critical vulnerability regarding the iron shovels?
No, it's not my problem. It's the track maintenance people. But maybe it will be fixed if we get to level 2, then we don't need axle counters. So then it's fixed, but we'll live with those axle counters for quite many years still. One here. I don't think we have the food yet. We are 15 minutes past. Hopefully no one is hungry.
It's actually good that you're getting questions because food is late.
Okay.
So
good.
many of these systems will fail safe, either stopping the train or making it go really, really slow. So I wonder why these attacks, where the goal obviously has been to stop the train traffic, hasn't succeeded. I'm also considering that you could close a really long part of the track just by stopping or making one train go really slow.
They never got to the safety system, those attacks. So they've been like ticketing systems or passenger information systems. So people can see where the trains are departing and things like that. And usually, I think in Belarus there were like physical attacks, people breaking to the trackside stuff and breaking it down. But it's only one location, not the whole network. Then that goes over, and then you will just drive slowly there. But yes, it is a challenge, and I know stuff that I could pretty much use to disable a lot of the railway infrastructure, but let's not talk about that.
I've read about things when pen testing OT environments that you can send a ping sweep to a robot and it will do a 180-degree turn in half a second. What kind of consequences are there to the train tracks if you were to do some, let's say, active scanning? Are they so severe as in other OT environments?
I never know. Hopefully nothing would happen, but people don't still let you even try to do that. We do have a lab coming up in Kouvola, so that's a location where we can actually install this stuff. We can have the onboard unit, we can have the radio network, and we can do all these like normal pen testing stuff. We can do it there, and the vendors do them also. Some of them are maybe good at it, some of them maybe not so great. And I don't know what the situation actually is on the market, like how good they are doing. I actually saw one vendor doing a similar test, but in a different industry, which I would think would be really secure, but it was not a very high quality test, let's say. I found a 0 day in about 15 minutes when I asked to do one thing. Basically a Linux box that had a world writable file that was executed by root at startup. So, and the threat model said that we don't even consider those people who don't have access to the system. So there was, I think it was a level 1 insider. So basically a guy who has access but is not root. So I found I don't even want to say what industry this is because you would all be scared.
In case you mentioned the PLC or SCADA, there are some companies, I think it's Siemens, that is really working the latest models with like the firmware, like hard coding. You mentioned that you are between PLC or a Linux box. It has a lot of code also. there has been a decision which one is going to be used, if keep pushing with the PLC SCADA, the more modern, or the from scratch using the Linux box?
We don't know even necessarily what's available. It's the market that decides basically. There will be some consideration on cybersecurity, like who can show us best that they are actually doing the correct things. Okay, the food is here, so we'll finish with this question. And then who sells the cheapest solution? That will be an important thing because there's not enough money necessarily. And that's one of the reasons why the cybersecurity can't really, in most cases, we can't actually tell that you're not allowed to buy this piece of crap, and they say, but it's so cheap. And then then you buy it and we'll try to protect it. Okay, we need to finish now. Talk to me after the presentation if you have more questions. Thank you.